Hello world, and welcome to the single responsibility principle video. This is going to be a practical overview using Kotlin that will hopefully give you a better intuition so as to understand what this principle is all about. The single responsibility principle is part of a 5-item set of principles called S.O.L.I.D, the 5 principles of object-oriented design. They were first introduced by Robert Martin, best known in the industry as Uncle Bob, back in 2000. It was a set of best practices to help developers create software that's easy to maintain and extend. The term S.O.L.I.D, however, was actually Michael Feather's idea, as stated in Robert Martin's 2004 book Clean Architecture. Feather told Uncle Bob that if he rearranged the principles order, they would spell out solid. Thus the name was born. While it was Uncle Bob that introduced the world to these principles, they are far from his discovery. They are the product of multiple software engineers' expertise and knowledge sharing throughout the generations. As stated, S.O.L.I.D is an acronym, each letter representing a single principle. It's the single responsibility principle that this video is about, the open-close principle, Liskov substitution principle, the interface segregation principle, and finally, the dependency inversion principle. Here's a fun fact. The title of this video is kinda misleading. It's merely a private joke. I'm using Kotlin in the title. These principles, however, are best demonstrated through UML diagrams or simple code that can be understood universally no matter what language you write. But even if you don't write Java, or C# or Kotlin for that matter, and you use any kind of object-oriented language, you will still be able to understand the code and the meaning behind it. Since I'm going to be using Kotlin for the bits of code, the title of course still stands, but I will not put it there as a first-class citizen of what this video is about. I wanted to point out this fact, that when we discuss high-level principles or ideas, programming language does not matter. It's simply a detail. You may have noticed the name of this principle is a mouthful, so I'm going to be referring to it from now on as simply SRP. But what is it? It's commonly described as each class should have only one responsibility. Well, yeah. Thank you very much. This is the title. But what exactly does that mean? What is a responsibility really? Let's see another very useful term. Each class should have only one reason to change. Well, maybe we're getting somewhere now, but we stumble upon the same problem. What is a reason to change? What constitutes a change? Is refactoring a change? Is a bug fix a change? It becomes apparent that we need a better way to gain intuition on what the SRP really is. Uncle Bob has said that this is a principle about people. What that means is that a reason to change would be reflected better if we looked at it from the people's perspective, the people who the change would affect. If you can imagine, say, a single change in the class affecting 2 different people or groups of people in your company, then this class would violate the single responsibility principle. In essence, this principle protects the interested parties, the stakeholders, the people who you could be working for. Now, a bug fix or a refactoring comes from the code itself. And since you are the developer, you are the interested party. And every class is your responsibility. So it doesn't count as a change. You will be fixing bugs for the rest of your career. And also keep refactoring the classes that you write, I hope. If you're a bit like me, then you know that an example speaks louder than 1,000 words of explanation or theory. So let's get into it. Let's use Uncle Bob's favorite example on the SRP, the employee class, to paint us an initial picture, and then we'll delve into a more complex scenario to really test our understanding. Take a look at this class. It contains 3 methods. The implementation is not important, but what is important in order to find out if this class violates the SRP is to identify reasons for change. What would be a reason to change this class? Who would request a change? Let's say you work at a company and you've written this class. The first method, calculate pay, could change by a request from the finance department. They probably need to change something in the taxes before an employee's payment. The second method, report hours, can probably change from the HR, the human resources department. They need to report overtime because the law changed. And the final method, save, can probably change from the technology department as the database technology has changed. So we have three different groups of people requesting changes for a single class. This breaks the rule, so it clearly violates the principle. We have identified reasons to change by discerning who could request changes for a class. So now we need to fix this. Now there's a couple of ways we could tackle this problem. The most obvious one would be to split those responsibilities into separate classes, and that's what we're going to do for this example. We're going to take the class pay calculator, and this would contain the calculate pay for method, and it would take the employee as an argument. So now you inject the employee into a separate class, so whenever a change for the payment comes, this would only affect the pay calculator class, not the others. The same way, we're going to create the work hour reporter that contains the report hours for method, and finally the employee data saver. That's a terrible name now that I see it in the slides, but whatever, let's just go with it. And it contains the save method that also gets an employee injected. So now, whenever a change comes from a different department, this would only target a specific class. No problems in your employee class and no problems in your other classes. So now, those three different classes plus the initial employee that would just contain the parameters for the employee, maybe his name, the ID, or whatever else you need, all conform to the single responsibility principle. Hopefully the essence of the SRP should be pretty clear by now, but I would also like to demonstrate one final analogy that I find really helpful, and this comes from the butterfly effect. What this is, for those of you who don't know, is that minor changes such as a distant butterfly flapping its wings could cause a tornado somewhere else in the world a few weeks later. What we're essentially doing with the SRP, or aiming to do, is to reduce or eliminate butterfly effects throughout our code. We do not want to do that here. We just want to be able to change something and don't worry about that change affecting something else in another time, in another place in our code. So if we think about it like that, then it's easier to picture that we need to isolate specific responsibilities or reasons to change in specific classes so that they do not propagate anywhere else in our code. They become contained, they stay there, and we are protected. We are safe from changes. And it's a very classical example that a developer makes a change in a class and the next day another class breaks or a unit test breaks. And you're like, why? Why did this happen? It shouldn't happen. Well, it happened because that change was in a class that violated the SRP.